All right, so we don't know what reaction they're talking about here, but we do have the change in enthalpy and change in entropy. And we want to know, okay, when is this reaction spontaneous? Low, high, any temperature, no temperature. So remember, if you don't have the formula, delta G is equal to delta H minus T delta S. I'll leave all the circles off here just for simplicity. And we want to solve for T. So if we subtract, well, first, we set delta G equal to 0. That's the tipping point, okay? For when a reaction is going to be at equilibrium and perhaps just increase the temperature just a tad one way or another to make it go left or right, okay? Spontaneous means we want the reaction to go to the right. Now if we solve for the temperature, we get this famous formula here. It's used in engineering and physics and here in chemistry. So we start with this. So all we need to do is plug in the values, but remember again that always the heats of reaction or enthalpy in reaction is kilojoules and entropy is joules, okay? So you want to take this 457 joules, okay, per mole per Kelvin technically, and you want to multiply, get it to kilojoules. So 1 kilojoule is 1,000 joules, so that's this many kilojoules, okay, per Kelvin. So temperature is delta H. Divided by entropy. Okay. Now in this situation, the units are going to nicely cancel here, and we'll be left with units of Kelvin. Let's not even do this on a calculator, because temperature is going to be a negative number. And we know that there is no such thing as a negative number. So we have to go back to the Gibbs formula and think about this. Delta H is negative 136 kilojoules, okay? And the temperature we're not sure of yet is multiplied by the delta S, and we'll use the kilojoules number here, okay? Now, if we plug in the lowest achievable temperature that humans can produce, let's just plug in 0 Kelvin. Okay, so if this temperature is 0 times whatever that entropy is going to be 0. We're going to subtract 0, so the delta G is negative. Okay? So what if we plug in, I don't know, 1,000 degrees Kelvin? A 1,000 degree Kelvin is pretty hot. So once again, we want to pretend like, okay, or we could just plug in a 10,000 Kelvin, which is hotter than the surface of the sun. And you can see how we're going to have a negative number and a negative number. So delta G is still going to be negative. So on our homeworks, we wouldn't really say the minimum temperature is negative whatever Kelvin. We would just say any temperature, it's spontaneous, because it's spontaneous at a low temperature of 0 or at a high temperature like 10,000. So the correct answer for this is any temperature. Okay? Thanks for watching. Please give a thumbs up on my awesome YouTube video. Have a great day, everybody.